Welcome to Learning and Thinking. In this video, we'll go over learning and different types of learning, how to make it happen, and we'll talk about thinking. Now, is thinking always a part of learning? Well, it depends on who you ask and the psychological theory that you subscribe to, so we'll dive into that as well. The primary questions that we'll address are, first, what is classical conditioning? Second, what is operant conditioning? And third, what do play and exploration have to do with learning? Throughout this, I'll make the argument that all four of these things, classical conditioning, operant conditioning, play, and exploration, are all learning when we get down to it. So let's define learning so that we have a working definition to go from. What we're going to call learning is any process through which experience at one time can alter an individual's behavior at a future time. So this is a very broad definition, and it's, a fancy way to say what you already know as learning. All right. Now think about different contexts when learning might be defined differently. Maybe it's performance on an exam or, actually making some sort of outcome or whatnot. But it's not that it necessarily does, but it can. All right. Now let's dive into that word that seems super common in that definition of learning. Let's dive into experience. What does experience mean? All right. We're going to define experience broadly as any effects of the environment that are mediated by the individual's sensory systems. Okay, so anything that someone can sense, that's part of their experience. All right, if they're not sensing it, it doesn't count. Okay, and if they are sensing it, we're going to count it. All right, and then let's talk about behavior at a future time, just to really break down this definition of learning. For behavior at a future time, it's exactly what it sounds like. Behavior at a future time is any subsequent behavior that's not part of the individual's immediate response to the sensory stimulation during the learning experience. Okay, so anything that's new that wasn't there before. Here's an example of how learning influences future behavior. Now, if you have a dog or anyone in your life, it could be a human, any sort of animal, you already have the gist of this, okay? So if I open a jar with treats and I give my dog a treat, then the next time he hears the jar, he comes running. Try it now. I'll open this jar and see if you can hear little dog feet scurrying. All right, so he came close and he sat like he does when he wants a treat. Here you go. Pretty basic stuff. Now, you can think of, different kinds of examples of when this happens, right? What if you hear this noise? All right. Did anyone salivate a little bit? I certainly did. And for me, I just opened a sparkling water. But for you, that sound might come along with whatever your favorite beverage is that comes in a can. Maybe it's a nice ice cold Coke, or hey, Team Pepsi. Maybe it's canned beer. Okay. If anyone watched that show Weeds back in the day, the main character always had a Diet Coke with her, and she was constantly opening these cans. And throughout the show, I'm thinking, man, I'm really craving a Diet Coke. And I was not craving a Diet Coke. I think personally, for me, Diet Coke is not my jam. But you can see, examples of this all around us. So, how did my dog learn that opening a jar means that he should come and run? Well, when he was a little puppy, I kept his treats in a jar. And every time I'd open the jar with treats, I'd give him a treat. And he would smell the treat and salivate. Over time, he would associate the sound of the jar with getting a treat. Simple. Just in the same way that we might associate, hearing a doorbell with a friend coming over, or a package arriving, or, a flower delivery, okay? Or, hearing that ping on your phone to let you know that you've got a message from a friend, or maybe a crush, or what have you, okay? So what we're talking about here is classical conditioning. It's a learning process that creates new reflexes. So let's dive in and define these terms. So a reflex is a simple, relatively automatic stimulus response sequence mediated by the nervous system. Okay, so you have to be able to, sense it, right? Your body is involved in this. That's the mediated by the nervous system part. And the reflex part is you're not really thinking about it too much. It's happening really almost without your awareness in some cases. All right. And then we've got our stimulus, which is a particular event in the environment. So in the case with my dog, the stimulus is the sound of that jar opening. His ears just perked up. All right. In the case of getting a text message, it's that noise, that message, whatever it is, to let you know that you've got a message. Or, hey, right, if you don't even, you keep your phone on silent, it's just seeing your phone light up, perhaps. Now, the response is the behavior that results from the stimulus. So in the case of my dog, the salivating, the coming and running and expecting a treat, all right? And then we've got another thing that's a part of classical conditioning, but something that we don't always think about too much. It's habituation. So we learn and we act reflexively, and we come running for that jar opening, or we go looking for that that ping as that maybe it's your crush texting you, right? But then something happens, and that stimulus is it's happening so often, right? Your crush is texting you all the time. It's no longer new or exciting, right? And so habituation occurs. It's a decline in the magnitude of a reflexive response when the stimulus is repeated several times in succession. So basically, we get bored. All right. So this is just a slide showing you how learning influences behavior. So we see the jar, treat. The treat produces salivation. Over time, the dog's associating the sound of the jar with getting a treat. Next time he hears the jar, he comes running, salivates, licks his lips. The whole gamut, right? Although he doesn't habituate too quickly. All right, so let's talk about the procedure and generality of classical conditioning. And I'm going to throw out some different terms here. They might sound confusing, but I think the acronyms help a lot, so you can tell them apart. And I'll show you a diagram next. All right, so we've got our conditioned stimulus, our conditioned response. These are the things that we're learning to associate with each other. And then we have our unconditioned stimulus and our unconditioned response. These are the things that we don't have to be trained on, okay? These are things that are happening already reflexively. These are things that we've already learned. So in the case with my dog, he's getting a treat and he salivates. The treat is the unconditioned stimulus, and the unconditioned response is the salivation. Now, when the unconditioned stimulus is paired with the conditioned stimulus, the jar opening is paired with the treat, then we see that the unconditioned response that's paired with the stimulus then becomes paired with the conditioned stimulus, okay, to produce a conditioned response. The dog is now salivating, coming running, and licking lips in response to the jar opening, even without the presence of the treat. So let's break down the process of learning a little bit more. And you can see all of these terms in a graph or diagram that's got a bit more context. All right, here's my mouse. So before conditioning, we've got a neutral stimulus, like a bell or the jar opening, and that doesn't produce any consistent response. Okay, this is just a sound in the environment, and it doesn't have any consequence for you, so you're not paying attention to it. And there's also an unconditioned stimulus, food. You don't have to, teach me too much to, know that if I see food, I'm going to start salivating, right? That's, a basic process that is, part of survival, right? We need food. All right. So unconditioned stimulus is food, and our unconditioned response is salivation. And then during conditioning, we see that our neutral stimulus, like a bell, a text message ping, that jar opening, is paired with food or whatever it is, right, that makes us feel something automatically. And because the neutral stimulus is paired with the unconditioned stimulus, you then get the unconditioned response, salivation. Now, after conditioning, right, and it depends on the context for how many times you would need to condition this, but let's say, you've got, a dog similar to mine, or, a teenager who's really excited, right? It might only take a couple times, or maybe even once, okay? So the neutral stimulus is paired with the unconditioned stimulus, and it produces the unconditioned response during conditioning. So we've got bell, food, salivation, bell, food, salivation, okay? And maybe it needs more time, or maybe, boom, happens just like that. After conditioning, you no longer need the unconditioned stimulus to get the response. Because after conditioning, you just need the conditioned stimulus, that bell sound, and that will produce the conditioned response, salivation. Now I want you to try this out. Design a process of learning. Okay, and this could be using your psych powers for evil, or you can use them for good, of course. So what I want you to do is think about what's something that you want to train your friend on. Do you want to train them to be happy every time they see you? Or do you want them to salivate every time they see you, right? You could pair yourself with food, and then over time, you don't even need the food. They just see you and they start salivating. I've had that happen before. A student, their sibling, I think her brother always would come home with food. And so he became her conditioned stimulus. Okay, because he always came home with tasty stuff. So, all right. So what's something that you want to train your friend on? And if you've ever watched The Office, you know that there's an example there where Jim, I think, trained Dwight to, let's see if I've got a stapler here. Jim trained Dwight, I think it was every time he stapled that he would give him an Altoid, or maybe it was every time he turned on the computer, something like that. And then Dwight would stick out his hand. So you can get creative with this. Do you want someone to stick out their hand? Do you want whatever? Okay, so what's something that you want to train your friend on? And then using classical conditioning, design how you would condition them. So be sure to define your unconditioned stimulus, your unconditioned response, your conditioned stimulus, and your conditioned response. Now, get creative with your unconditioned stimulus. It could be something like food. That's an easy one. But also think about other things that we respond to without, without much training. So if you hear a loud fire alarm, right? Immediate panic, okay? Or if you hear an ambulance going down the street, right? No one has to train you that if you're standing in the middle of the road and you hear this big loud ambulance coming at you, that you need to get out of the way. So the unconditioned stimulus should be something that without much prior learning, someone already has. Now, we've mentioned food as stimulus, but let's dive a little bit deeper and talk about hunger and diet and how that connects to learning. Now, think about epigenetics, okay? In the Dutch famine study, we saw intergenerational learning where pregnant women who experienced famine during World War II actually had genetic expression differences, epigenetics, in their children and in their grandchildren in response to hunger. Okay, so that's an example of learning that we can see on a much larger scale, right? That takes generations for us to see, but we can see that there's a connection there and that our genes are involved in that. All right, so let's go a little bit deeper into this, broad scale learning, okay? We see that low nutrients prenatally often leads to thrifty phenotypes. They're doing more with what they have. So they're storing more fat, and where else have we seen this? I just told you, Dutch famine study, okay? Now, these are both examples of how genes and environment interact. But what about culture? Does your culture influence your hunger or your diet and how you learn to respond to those different cues? Let me give you a quick example. I'll give you two of this, okay? And this is, at a very small scale, but you'll get the idea. My nephew could, we'd be driving by, going to, the sports store to pick up whatever, and he would see what we all know, the Golden Arches. And he would say, fry fries, from the back seat. And he's, shouting about these fries. And my sister would explain to him, sorry, bud, there are no fries. And lo and behold, if we just looked back at him, he would be pointing and he would see the Golden Arches. So he had connected that those Golden Arches meant those tasty fries. Okay. And you don't have to be in the US to learn that, right? Those Golden Arches are a worldwide symbol. But of course, they're more common in some places than others. So let's go into an even larger example than just one kid loving French fries. All right. Oh, let me tell you one more example. My other nephew, we were driving and I said, okay, we can go. He was visiting me in California and I said, okay, we can go wherever you want. It was, a special treat for him. And he said, Waffle House. And I said, I'm sorry, we don't have Waffle House in California. And he goes, I want to go to Waffle House. And so I'm sitting there thinking, I'm driving, right? And I'm thinking, well, how do I get this kid Waffle House? And I'm like, I know you have Waffle House, where you live, but we just don't have it here. And he's pointing at IHOP, International House of Pancakes. And so, in my mind, I'm thinking, okay, is it really waffles? He's associated it with waffles, but is waffles like this broader term? What has he learned? I don't know the full context here. And I can't remember if I explained that it was pancakes instead of waffles and asked him if that would be okay. But I do know that the experience ended with him getting a smiley face, waffle or pancake from IHOP, and he was very happy. Okay, so those are two examples from, little kids and associating, symbols that we see around with different foods. But again, like I said, let's go to an even broader cultural level. Okay. And let's connect this to diet as well. So, before I go into this, I want you to consider, how your culture has impacted your diet. Okay. So, now that you've done that, let's dive into this. So within a culture, we know that genetic differences are the primary determinants of who becomes obese, but across culture, environmental differences play a substantial role. How do we know this? Well, researchers or someone was paying attention. They noticed that obesity was high among the Pima Indians living in Arizona, which is in the US, right? It's a developed country that has high access to high-calorie foods. But among their genetic relatives in Mexico, where their diet was mostly grains and vegetables, and there wasn't much access to high-calorie foods, okay? So this wasn't done until the 1990s. So as our world changes, you might have to look for different examples to see this same effect existing now. So, what is it, right? Is it a McDonald's coming to town? Is it having more access to high calorie foods, right? Is it having access to, the diet that, your family is used to, right? Okay. Now let's go back to our environment a little bit, okay, and our brain. So I don't know about you. Does anyone else have a sweet tooth? Okay. I certainly do. And, you've seen all these different products, right? Oh, there's, oh gosh, what do they have? There's sugar. Okay, I'm talking about Coke too much in this, but, Coke, right? They advertise it, like there's like regular Coke and then there's Mexican Coke made with real cane sugar. And it's, those, a cold glass bottle Coke with, real cane sugar. Oh man. Take a sip of drink right now. It's not Coke though. All right. And you've seen, right, stevia and sweet and low, and what else do they have? Monk fruit or something, right? They use honey, agave, all these different sweeteners. Okay. So you know this, or maybe you don't. Maybe you just like all sweet things the same. But your brain already knows this, that all sugars aren't the same. Okay, so let's dive into this a little bit more. Not only do you notice it because of the taste, but fructose doesn't produce satiety or fullness while glucose does. Okay, so if you remember, there was a marketing campaign, I want to say maybe early 2000s, and they would show a mom giving her kid, like an ice pop or something, and the other mom would, kind of scold her and say, "What are you doing?" And the mom would say, "Oh, it's, high fructose corn syrup is fine, And they were trying to promote the high fructose corn syrup is fine. But from this class right now that nope, it doesn't produce the same satiety or fullness that glucose does. The brain interprets these differently, and this might influence obesity. So studies have found that high exposure or consumption of fructose early in life, okay, including in the fetal stage and in infancy, can alter metabolism, neuroendocrine function, appetite control, and it increases the likelihood of later obesity. So a lot is happening before we even realize that we're learning, before we're even hearing that bell and pairing it with food, before, we are really making agentic choices. A lot of this is, in, it could be, epigenetics, it could be our environment and our culture, and it could be our exposure in early life. Now, as we're talking about dieting and hunger and learning, I want you to think a little bit more critically about this topic, okay? And one way that I want you to think about it is ask yourself, what are some of the ways successful dieters achieve their goals? Okay. Is it just diet? Is it just exercise? All right. And then as you're thinking about that, I want you to think, how do conditioned stimuli and the availability of many foods with different flavors contribute to appetite and obesity? So Is it just diet? Is it just exercise? Well, we know that only dieting leads to lower basal metabolism, and that helps the body to more efficiently convert food to fat. Um, it doesn't take too much learning to know that that's not actually helping with weight loss. Now, exercise leads to burning calories immediately, and it builds muscles, which burn calories faster than other tissues, even when at rest. Okay, so through classical conditioning, any cues that have previously signaled an opportunity to eat, such as, right, smelling some good food, that IHOP sign, the Waffle House sign, the sound of that jar opening, or even, right, looking at the clock and seeing that it's dinner time, can all bring on a sudden surge of appetite. Okay, so these are also things to consider, right? It's diet, exercise, and it's our environment. Okay, experiments with animals show that the sight and smell of a new food can result in renewed activity in appetite-stimulating neurons in the hypothalamus after the animal has been sated on a different food. Laboratory animals that can regularly choose from a variety of different tasting foods eat more and become fatter than do animals that have only one food choice, even if the nutritional content of the various foods is identical. So, back to my question, how does this contribute to appetite and obesity? Well, people too eat more when offered more food choices. Okay, so, if you're trying to get someone to eat more, you offer lots of different varieties of things. I mean, think back to any holiday that you've celebrated, and if you maybe felt a little fuller than you normally do, right? Were there new foods there? Were there a variety of foods? Do you think that any of that may have impacted you? So, diet, exercise, and our environment, okay, are some of the ways that these conditions stimuli and the availability of many foods with different flavors are impacting us. All right, so you get it. We compare an unconditioned stimulus with a conditioned stimulus, or unconditioned stimulus with a neutral stimulus. That becomes conditioned, and it starts to produce the conditioned response. But what can happen after that conditioned stimulus conditioned response pairing? Well, a couple things can happen, okay? Habituation can happen, right? Where you just kind of stop responding to it. It's no longer all that interesting, okay? Extinction can happen, and we'll call this extinction in quotes because we can also have spontaneous recovery. All right, so extinction is without the unconditioned stimulus. Eventually, the conditioned stimulus will no longer produce the conditioned response. Okay, so if you open the jar enough times and the dog doesn't get treats from it, eventually, it's no longer getting that conditioned response of, coming and running for the jar opening, right? It's not producing treats. But like I said, we can have spontaneous recovery. So after time, the conditioned response might occur. Okay, so occasionally the dog's ears might perk up when he hears that jar opening or whatever it might be. Okay, you're texting with your crush, right? And you habituate to that. And then all of a sudden you break up. And then every time you hear that dinging sound, it's no longer producing a message from them. But then all of a sudden one day you hear the sound of a message and, you start thinking of them. Okay. And that's spontaneous recovery. All right. What else can happen? Generalization can also happen where the conditioned response can occur in response to similar conditioned stimuli. Okay, so it's not just the sound of a jar opening, a glass jar. It's the sound of, a plastic jar. It's not just the doorbell. It's a knock on the door. It's your neighbor's doorbell. It's, right, all these different sounds. Okay, you can generalize to those different sounds. Okay, and let's talk about one that you've probably experienced in your life, which is discrimination, right? So, your crush is texting you, and so is, your group chat, right? Your study group. And so your phone is just going off the wall, and you're like, hey, wait a second. I need to discriminate between when my crush is texting me, which is, I want to check my phone, and, the group chat, which, you're taking a break, and, it's not really time to respond to them, maybe. Or, right, you don't want to get quite as happy about that, maybe. Anyways, at that point, you might set different tones, and you'll start to discriminate between the different conditioned stimuli. Okay, so over time, your conditioned response will occur only in response to one specific conditioned stimulus. Okay, so if you sleep in a house with other people, okay, do you wake up to their alarm clocks? Or does only your alarm clock wake you up and you learn to sleep through the rest? If you've learned to sleep through the rest, that's discrimination. However, if you wake up for, anyone in your home, if their alarm clock goes off and you wake up, that's generalization. And we can see here in this graph, on the x-axis, we have the successive trials 3 minutes apart. And on the y-axis, we have the amount of saliva produced. Okay, this is data from Pavlov, who, does lots of work in learning, or did lots of work in learning. Okay, and we can see at the first trial, we've got lots of saliva. Second trial, less, but still a lot. Less on the third, less on the fourth. At the fifth, we're seeing there's some extinction going on, right? They're not getting they're not getting the conditioned response anymore, okay, without the unconditioned stimulus there. And then some time passes, and then boom, right? The conditioned stimulus is now producing some sort of conditioned response. It's not quite as strong as those other ones, but we're still seeing it. So there's our evidence of spontaneous recovery. Let's talk about two different theories of classical conditioning, and I want you to think about which theory takes thoughts into account. Okay, which theory takes into account that we're human. We have this thinking component of learning. Okay, so let's take a look at this top theory, the stimulus response theory of classical conditioning, and then we'll compare it to the stimulus theory of classical conditioning. All right, so according to the stimulus response theory, conditioning produces a direct bond between the conditioned stimulus and the response. Okay, so these two are paired together, and the conditioned stimulus forms a direct bond with this response. And then if we look down here at the stimulus theory of classical conditioning, we see that the conditioning produces a bond between the conditioned stimulus and the mental representation of the unconditioned stimulus. And that in turn produces the response. Okay, so you see that this is really mediating the relationship between the conditioned stimulus and the response. Okay, so in the stimulus theory of classical conditioning, they're saying, wait a second, when the conditioned stimulus is presented, it's not just that it goes straight to the response, but that makes someone think of the unconditioned stimulus, and that's what's causing the response. Okay. So support for the stimulus theory comes from experiments showing that weakening the unconditioned response through habituation after conditioning also weakens the conditioned response. Okay, so we have evidence for the stimulus theory of classical conditioning. And now I want you to think about which theory takes into account our thoughts. All right, so the stimulus response theory of classical conditioning is from behaviorism. So this is Pavlov was saying, was theorizing that animals don't learn a direct stimulus response connection, but rather they learn a connection between the two stimuli, and the conditioned stimulus and the unconditioned stimulus. Okay. Now, Pavlov, true behaviorist very early on, and there you go, right? There's no thinking involved here much, right? Okay. So Watson, another behaviorist, said, hey, there's got to be something going on. There's got to be more going on. There's got to be an unobserved event going on in the animal's mind. So, he's saying, well, yeah, behaviorism, sure, but we have to take into account this other thing. And this went against what a lot of people, wanted to study because they only wanted to study observable events, which makes sense. But when you think about what someone could observe about you versus, what's actually going on inside your brain, right? That there's a lot more going on that can't be observed. So, we know that taking into account mental events or things that we can't see can actually be really useful in science. Now, cognitive scientists and psychologists, right, we're getting more involved in this, and they said there's absolutely thought going on, and they came up with expectancy theory. All right, so this is a more cognitively based theory, okay, and so this is in contrast to behaviorism, which is cutting all of that out. And we can see it's the, same basic thing, but instead of having, we've got our unconditioned stimulus, our unconditioned response, our conditioned stimulus, and our conditioned response. But instead of just having treat, salivate, the treat's paired with a jar opening produces salivation, we're seeing that there is a whole repertoire of behaviors that's produced. So there's an expectation, and that expectation is producing even more responses than the original, stimulus did. So some key things to pay attention to in classical conditioning. The conditioned stimulus must precede, it must come before the unconditioned stimulus. The conditioned stimulus must signal heightened probability of the occurrence of the unconditioned stimulus. Okay, so it's got to be a good marker for the animal to know that the unconditioned stimulus is about to occur. Now, conditioning is ineffective when the animal already has a good predictor, right? Animals are smart. We're smart. We know sometimes, right? We know when we're getting tricked. So, this expectancy theory is really filling in some gaps. It's helping us to make sense of the observation that a conditioned response is often quite different from, the more limited response of the unconditioned response. Okay, so we see some support for the expectancy theory from research showing that conditioning occurs mainly when the new stimulus provides information that truly helps the animal to predict the future in some way, right? It's helping the animal predict the arrival of the unconditioned stimulus. All right, so check out these links to Little Albert. Pause this and come back. I'm not exactly sure, the best way to do that with how I record. But anyways, so pause, watch it, come on back. Now, what's happening in Little Albert is we're seeing that a loud sound produces, crying, right? Feeling scared, feeling fear, feeling threatened. Okay. And over time, when that loud sound, that unconditioned stimulus, is paired with the conditioned stimulus of the white rabbit, right? We see that the white rabbit starts to produce the crying, the fear, the scariness, right? And then we see generalization. So it's not just the white rabbit, but it's also that Santa beard, it's also, fluffy things and whatnot. And some sketchy things happen with little Albert that I want to draw your attention to as far as ethics go. So not all research, right, is on the up and up. We have our institutional review boards, our IRB, our Human Rights Review Board, HRRB, to try and, make sure that what we're doing to people is, safe and fair and all of these things, but it doesn't always happen. So in little Albert's case, something that didn't happen was he was never desensitized to that footage. So we don't know if he went on to, just be fearful of everything, soft and fluffy in the world, because that wasn't done in the original experiment. The other thing that we don't know is who little Albert actually was. And so it's not like someone could go back later and, reconcile this. And the other thing that should definitely raise that alarm bell for you is that Watson burned his notes from this study. So I don't know about you, but if, I don't know. I watch some questionable TV. And there's always an instance where it's like, well, let me see the text messages. And the person says, oh, they're not here anymore, right? They've been deleted. So, that raises my suspicions more. So we don't know exactly why he burned his notes, but I don't know about you. Sounds a little bit questionable to me. Let's talk about operant conditioning. So operant conditioning is another way to learn. But it's a little bit different because it involves acting on the environment. Okay, so whereas classical conditioning is a passive situation, the animal doesn't have to actually do anything. These stimuli are being presented and then they're responding. In operant conditioning, we see that an action has consequences on its recurrence. Okay, and this entails learning about the conditions and consequences. So under what conditions do I need to perform what behaviors to produce this consequence? Operant responses are when the animal operates on the environment to produce some effect. Here's a quick example. Okay, pick up your phone if you have one and try to unlock it. Okay, back in the day, you used to put your thumb on the phone to unlock it. Okay, but if you just put your thumb on your phone in any spot, it doesn't work. Okay, how do you unlock your phone? Okay, do you have to show it your face? Do you have to put a specific finger on the phone, right? Do you have to enter a passcode? Does any passcode work? Or is it the specific conditions, right? The specific, pattern that you have to put in, or numbers, or what have you? In short, you've got the gist of operant conditioning. To learn more about operant conditioning, let's take a look at this cat in a Skinner box. And yes, B.F. Skinner, behaviorist, author of Walden 2, great book. I recommend you check it out. I think it's a pretty short read. I read it years ago. I forget. I don't know if a high school psych teacher recommended it. I want to say like my high school calc teacher or something mentioned it. Anyways, it was great. Maybe it was middle school. I don't know. Anyways, I appreciate those sorts of books. So B.F. Skinner was really leading the way in psychology and pioneering the way for operant conditioning. And so one of the things that he designed was a Skinner box. And you could think about, other examples of Skinner boxes. Think about the Skinner box that you're in right now. But let me explain what it is before we go too much further. So we see that this cat is in a box. Whoops. This cat is in a box and they're trying to figure out, how do I get out of this box? Okay. So they're doing all sorts of things. And if you've ever put a cat in a box, right, they want to get out, probably, unless they've chosen to be in the box. But anyways, there's some sort of reward out here, right? The cat wants to get to the food. And so they're trying to figure out, how do I get out of here? What response will get me out? And so at first, we see that the cat is doing lots of different things. They're scratching at the bars a lot. They're pushing at the ceiling. They're digging at the floor. They're howling, right? Maybe they're jumping. They're doing all of these different things, okay? And then one time they press the lever and the box opens. They're able to go out and eat the food, okay, and get that reward. Now, after many trials in the box, these other responses are fading away, and the one that produces the consequence that they're looking for, pressing the lever, is the one that they're doing the most, okay? So think about, right, you have, a key ring full of rings, right? Which one is going to get you, into the room that you're trying to go into? Or if I'm sure we've all done this, right? If you've ever tried to, go in somewhere and you push on the door and the door stays there, and you either see the sign or someone tells you, or, you look around looking a little bit embarrassed. And you're like, oh, right, I need to pull it, right? So you learn to differentiate as well. So when the cat actually gets out of the box, we see that they're getting the reinforcer. They're getting a stimulus change that follows an operant response and increases the frequency of that response. So in the cat's case, they're getting food, okay? Now, why are we calling it a reinforcer? Why aren't we calling it something else? Well, this goes back to behaviorism. First, it makes no assumptions about anything happening in the mind. Very, very behaviorist, right? Let's keep cognition out of this. The second reason to call it a reinforcer is that it only refers to the effect of the stimulus on the animal's behavior, right? Behaviorism. We're still not including any thoughts here. So why call it a reinforcer? First, it makes no assumptions about anything happening in the mind. And second, it only refers to the effect of the stimulus on the behavior. All right, let's check out this cumulative response curve. We can see Skinner here with his rat. And on the x-axis, we have time increasing from left to right. And on the y-axis, we have cumulative responses increasing from none to many. And you can see that at the beginning of time, the rate of response is pretty low, okay? It's slow. It's not happening all that quickly. But then over time, we see that the rate really increases, okay? And this is a typical response curve for a rat learning to press a lever in a Skinner box. And, it's similar to what we see in other situations, right? We're slow to learn something, and then boom, we get it. And we're, we want to get that reinforcer. So we're going to act more and more quickly to get it. There are a couple of principles of reinforcement within operant conditioning to pay attention to. The first is shaping of new operant responses. Shaping is what you do, when you're trying to get someone to do what you want to do without fully telling them, right? So, when the person gets closer and closer to doing the desired response, right, you reinforce it until the desired response finally happens and it can be reinforced. Okay, so, if you want to get someone to do the dishes, then you reinforce them going into the kitchen. And then you reinforce them going closer to the sink. And then you reinforce them actually doing the dishes. And then, right, and then they're actually doing the dishes. They're doing the desired thing. Okay, and you can think of other examples in your life of, when you've shaped someone or when they've shaped you. Okay. Now, we learned about extinction in classical conditioning, and this happens in operantly conditioned responses as well. So remember when we were talking about classical conditioning, we called it extinction in quotes. Similar here, okay? An operantly conditioned response will decline, okay? It'll become, less common, and it'll eventually go away or disappear if it no longer produces the reinforcer. And here we're calling it extinction in quotes because it's not true unlearning, okay? Similar to what we learned in classical conditioning, if, some time passes, we can still see a spontaneous recovery of the response, even if it's been, some amount of time. So is it true extinction or is it true unlearning? We're going to say no. Now, there are different schedules of reinforcement that produce different patterns of responding. So before we dive into this graph, I want you to think, if someone wanted you to do something and they wanted you to do it often and a lot of it, right? How often would they need to reinforce you, right? How often would you need to get that consequence, right? If it's a job, how often would you need to get paid? All right. So we can see four different schedules graphed on here. And let me walk you through the graph first. So we're going to move on the x-axis from time ranging from 0 to 80 minutes, and then number of responses from 0 to 1,000. But what you really need to pay attention to is on the x-axis, we're seeing from, low time to higher time and number of responses from lower to higher. Okay. And just eyeball this graph. Which schedule is producing, right, the highest number of responses and doing it most quickly? Well, we're seeing the fixed ratio is doing that, right? Which one is slowest? The variable interval. So let's dive in and we'll talk about fixed ratio, variable ratio, fixed interval, and variable interval. Now we can see that there are, two different types here. So fixed and variable. So a fixed ratio schedule is when the reinforcer occurs after every nth response, where n is, some whole number greater than 1. So, every time, every 6 times you do something, you get something, right? That's your, the fixedness of it. Okay. And we see that. So with our fixed ratio schedule, it's a fixed amount, right? And then with our fixed interval schedule, it's a fixed period of time has to elapse between one reinforced response and the next. Okay. So 2 weeks have to pass before you get paid. Okay. If you, respond before that, it doesn't matter. You're not going to get that reinforcer until the time has passed. Okay. So we see that people who get like commission, for example, right? They're often producing more, right? They're trying to, get that more often, whereas fixed interval we might see as more as like a salary job. People are getting the reinforcer, on a consistent schedule, and yeah, they're going to do the work, but they're not really hustling quite as much, right? All right, now let's hop into the variables. Variable ratio is similar to the fixed ratio schedule, okay, except that the number of responses required before the reinforcement is varied. It's unpredictable around some average. So, you get paid, about every time you finish a task, maybe every like 2 or 3 times, okay, but it's not every time that you do it. And then we have the variable interval schedule, which is similar to our fixed interval schedule, except that the period of time that has to pass before the response is reinforced is, right, varying, and it's unpredictable, again, around some average. So this is like, maybe if you work for a small company, I think this is common when I've talked to students in construction, you get paid about every 2 weeks, but right, sometimes, the job is ending sooner or later. And so it's variable on, whether you get paid every, week, 2 weeks, 3 weeks, right? It just depends. Now, we've heard of reinforcement, but not all types of reinforcement are the same. So we already know that reinforcement is any process that increases the likelihood that a particular response will occur. Now, positive reinforcement occurs when the arrival of some stimulus following a response makes the response more likely to recur. Okay, so a positive reinforcement, when I tell my dog, or when I, give my dog a treat, right, then he's more likely to sit. Okay, he sits, right, and he gets a treat, right, positive reinforcing. Now, negative reinforcement occurs when the removal of some stimulus following a response makes the response more likely to occur. Okay, so this is something is being taken out of the environment. So here's an example of a negative reinforcement, right? You are, fast asleep, you're comfortable, and then you hear that alarm going off. Okay, let's see if I can set a quick alarm to go off. Okay, so how do you stop your alarm from going off? Well, you turn it off. Okay, that's negative reinforcement. So the removal of some stimulus following a response, the alarm stopping making that noise, makes the response more likely to occur. All right, so you're more likely to turn it off if, to press in a certain area of your phone or the alarm clock or whatever it is in order to get that alarm to stop going off. You're easily confused because, you think negative and you might think punishment, but punishment is different than a reinforcement. Reinforcement is increasing the likelihood that the response will occur. In contrast to reinforcement, punishment is a process through which the response, the consequence of the response decreases the likelihood that the response will occur. Okay. So positive punishment, the arrival of a stimulus decreases the likelihood that the response will occur. All right. So, you touch the hot stove and you burn your hand, right? The burning is the arrival of the stimulus, and, right, in the future, you're less likely to touch that hot stove. Negative punishment is the removal of a stimulus that decreases the likelihood that the response will occur or will recur. So here's an example of that. You break some house rule and your parents take away your phone for, a week, right? So they're trying to decrease the likelihood that you're going to keep breaking that rule by removing your phone from the situation. So putting reinforcement and punishment together in a chart, we can see that the response rate varies, right? So to increase the response rate, we have reinforcement. And to decrease the response rate, we have punishment. And the response that causes the stimulus to be presented, right, is positive. And the response that causes the stimulus to be removed is negative. And these different response rates, right, these different ways of reinforcement and punishment can be used for discrimination training. So we can learn that, okay, if we press, the red lever, this happens. If we press the blue lever, this happens, right? If you press, repeat on that alarm, that's only going to come back. But if you press stop, then it's actually going to stop the alarm from happening, right? All right. So we've got different types of learning. We've got classical conditioning, operant conditioning. Now let's talk about play. Because in the natural environment, learning is promoted by play, exploration, and observation. These are fun things, right? I like to play. I like to explore and observe, right? These are things that kids do. So Gruss had a theory of play where he says play is practice of species typical skills. Okay. And this is what Gruss observed in his theory and what he put together. Okay. So young animals play more than adults of their species. Species of animals that have the most play learn the most. Young animals play most at the skills that they need to learn. Right? So think back to your childhood, think about what you did as play, and think about what you do now as an adult. In humans, it's really interesting because, especially now with how rapidly the world is changing and how the skill sets that we need as adults might be so disparate from what we, were trained for as kids. And the ways that you played might vary a lot from how your parents played or the previous generation. Because, right, what we need as adults can change. So, funny enough, I used to pretend to teach all the time, and That's how I liked to play. And look at me now. Here I'm doing that. Okay. Play involves lots of repetition, right? So you're doing the same thing over and over again, but it's not exactly the same thing all the time, right? Because, it might be a little bit different, right? You're working through problem solving and different challenges, and play is challenging. If it's not challenging, it's boring. Are you going to keep doing something that's boring? Nope, right? Do you have to convince kids to play? No, it's naturally, right, stimulating their brains and helping them to engage in these different contexts and to develop the skills that they're going to need, right? I used to play library, and I would pull my books off the shelf before I could even read, and I would pretend to make up stories about what the word said. And, I was getting ready for these adult behaviors, right? What I would need, what was it? Tag, right? Catching someone, right? Chasing after someone, catching them, hide and seek, right? Practicing social cognition, practicing that, I can know something different than someone else, but I have to do it in such a way that they really don't know that thing, right? So lots of skills that we practice through play. Now, we don't always play, but we live in a social world, right? We have different ways of learning. It's not just play. We can learn from doing things ourselves. We can also learn through social learning, okay, which occurs in a situation when one individual starts to behave similarly to another, right? So if you, go out to, dinner at a friend's house, right? You learn the customs of how they eat at their home, and you start adapting to those behaviors, right? If everyone is, using special utensils, then you're going to try, right? To use those utensils. If everyone is, sitting a certain way, or one of the easiest ones is if everyone's drinking, right? What are you going to do, right? You're going to drink. Maybe you're not drinking alcohol, right? But you're going to make it look perhaps as if you're behaving similarly to them. If you've ever seen a child in, social setting, right? You've seen this happen. Absolutely. All right. We also learn through observational learning, which is where we learn from watching other people. So we can learn how to, how to order at a restaurant from watching other people. We can learn, how to do so much from watching other people. There's a park by me, and sometimes it's locked. And so how do you get in? Well, I watch other people and I see how they get into the park, and boom, now I've learned how to get into the park. It's jumping the fence. Anyways, okay. And then we also have vicarious reinforcement, which links back to operational conditioning. So we have the ability to learn from other people and the operant conditioning that they go through. So if we see our sibling do something and they get money for it, right? Your sister loses a tooth and she gets, I don't even know how much the tooth fairy is leaving these days, but let's say, loses a tooth, gets $1, and you're like, hey, I want $1, right? So you're like, all right, which of these teeth needs, is ready to come out. We also learn through what other people, right, get punished for. So if, we're watching our sister and, she, right, touches the stove and it's hot, and she says, ow, right? We can learn that, something bad is going on there. Now, of course, we're curious and, we might still do that thing, but we have some sort of idea of what it is going into it. And as we wrap up on learning about learning and thinking and play and how they all tie together, I'll leave you with a quote from the psychologist Abraham Maslow, who you might recognize from Maslow's hierarchy of needs. He said, almost all creativity involves purposeful play. I hope that sinks in and that you think about that as you go through and move through the rest of your day. All right, have a good one.